This conference will now be recorded.
Yeah, hello students. Hello students. In the last class, we have discussed about transaction concepts, how transactions are executing, schedules, concurrent schedules, serial schedules, and all we have discussed. Okay. And moreover, before me continue, is it audible and visible? Is my okay? Fine. Okay. Chalo. Fine. Now I'm going to discuss a concept of recovery management. So means like any electronic and electromechanical devices, even a database system prone to errors. If any error occurred, then it may causes a failure, and if failure occurs, it may causes loss of some information. If loss occurs, then database system has to recover from the failure. So means the database system state should always be in the consistent state, correct state. That concept I am going to discuss in the topic of recovery management system. Recovery management system, and we will discuss in briefly about indexing also in the today's lecture. Now, as I just now I told you, like any electronic and mechanical devices, even a database system, go for a failure. Now, what are the possibility of a failures? Possibility of failures. A failure may occur in the transaction. We can call a transaction failure. Transaction failure means suppose you are executing a transaction which is causing some condition to be failed, so that the transaction has to be stop its execution, or else user may terminate the transaction. And there may be failure due to disk failures due to disk, like disk crash occurs. There are crashes on the disk drive, so that read write head on the disk cannot read the respective data values. And next is head crash occurs. So means whenever a read is occurred from the disk using the read write head, that head crashes occurs, then also it cannot able to read the data. And there is a fire accident in the server room, that also may causes loss of data. A fire accident occurs in the server room, so means all the disks in the server room got burned or burned, because all the disks in the server are burned, causes loss of data in the disks. In all of these cases, we are losing some information. It requires to recover the lost information. Okay, in order to recover the data from the lost information, in order to recover the lost data, database system has to maintain some details about the operations or transactions that are executing inside a system. So based on the data it is going to maintain about the operations or transactions executed in a database system, if any crash occurs, that information will be useful for recovering from the failure. Okay, now first, before I proceed, how it is going to recover from the failures, let me explain how data is organized in a database system. Here, data is a huge quantity of the data. Database is a maintaining huge quantity of the data. That huge quantity of the data is going to be maintained in the disk drives. This disk drives generally called secondary storage devices. Secondary storage devices generally consisting of magnetic disks. Right? Okay. Now these are called secondary storage devices, and moreover, secondary storage devices are slower one, not the faster one. These are the slower one. Slower means with respect to the accessing time. But whatever the data you wanted to process, first it has to bring from the secondary storage to main memory. From the secondary storage to main memory, it has to be bring. Fine. Now compare it to the size of the disk. You know the size of main memory is less. So that any data that is to be processed, that has to first bring from the disk to main memory. And to transfer data from the disk to main memory, it has to locate in which block, like disk consisting of memory blocks, like say block 1, block 2, block 3, likewise, or else block A, block B, and so on, assuming. Then it has to bring a block of data from the disk to main memory. So means transfer between disk to main memory is called a block transfer. So means even a single byte of information is required, which is available in the disk. First, it has to bring the whole block that containing the data has to be bring from disk to main memory. Means data transfer between disk and main memory is a block transfer. So that the required block has to be bring from disk to main memory. From main memory, after it is bringing data into main memory, data has to be processed by whom? The processor. We can call CPU has to process the data, like addition, subtraction, whatever it may be, updation, deletion, based on some conditions. What CPU should do? CPU will make use of the registers to update the data. Say assuming the register R1, and register is capable to store only 1 byte or 2 bytes of information, or we can call one word information. So that this register is capable to store only a particular data in the memory block, only a particular data. Suppose CPU wanted to perform operations on a particular register R1, that in that register that A is going to be copied. So means the data transfer from memory to CPU is only a data transfer, not the block transfer. Means entire block not required to be moved from main memory to register. It requires to move only required data from the block into a CPU register. Okay, it is a data transfer. And it is a block transfer. Now it has to perform the required operation. CPU has to perform required operation on the particular attribute. Then it has to transfer the data into the main memory. Then from main memory, it has to be transferred to the disk. Okay, from main memory to CPU, from CPU to from main memory to CPU, then again from CPU to main memory, from main memory to disk. Okay, this is actual operations. And moreover, first always the disk block has to be bring from disk to main memory, and these disk blocks are called physical blocks. Here these are called physical blocks. And the data in it will be considered to be the permanent data. Okay, the data in it will be considered to the permanent data, and whatever the updates are done, and that update should be affected to the disk. Keep in mind, whatever the updates are done by a transaction, that update should become permanent, that is affected only to disk storage. Okay, now whatever the data that is bring from the disk storage to main memory is called buffer block. Okay, now generally what CPU will do is CPU is going to read the required data from the buffer block and perform operations on the buffer block. but the updated buffer block is not required to be immediately updated to the disk. That is possible only when you execute a commit operation. When you execute a commit operation means this buffer block is going to be updated. This updated buffer block is going to be updated to the disk whenever it is performing the output operation. Here, in addition to read and write, I'm going to discuss two more operations called input and output. Input and output. Let me explain. Suppose there is a transaction. Suppose there is a transaction T which is depositing 1000 rupees into account A. Depositing 1000 rupees into account A requires what operations? It requires to get a buffer block that contains A in the disk into the memory, which contains A in the physical block disk to main memory. So to get a buffer, to get a physical block from disk to main memory, it requires to use an operation called input operation. Input of buffer block A. BA I am writing. So here my convention is, it is to get buffer block. It requires to get a physical block from the disk that contains A. I am calling BA is indicating that physical block containing the data A, BA, so that it is going to bring disk block is going to be bring into the main memory. It is going to become buffer block. Then what it requires here? It requires input. Next, from the buffer block, it cannot move the whole block from main memory to CPU register. It requires to perform a data transfer. So data transfer requires only read operation, means from the buffer block it requires to read the value of A. Okay, after reading the value of A into CPU registers, it has to perform some operations. Depositing 1000 rupees makes A plus 1000. So register value is to be get updated. After updating, it has to perform a write operation, write A. It is read A. After read A, after performing updations, it has to perform write A operation. After it performs a write A operation, what it has to do? This is affected only to the buffer block, not to the physical block. Even whenever you write a commit operation, it is updated only into the buffer block, main memory. And do remember, main memory is a volatile memory. Volatile memory means the contents of main memory can be lost if there is a loss of power. If there is a loss of power, the data that is written in the buffer block is going to be lost. Now what it requires? This buffer block content has to be output to the physical block disk. So that is done by using output operation. So here it requires to perform output of BA. And do remember here, once transaction is committed, we have discussed that it cannot be undone. Means it is becoming permanent. This point we are discussing. Once commit operation is executed, we understood that the transaction is completed. But this commit is also affecting only into the buffer block. Then how system ensures that is committed? If this committed transaction updates are not affected into the main, not affected into the disk block, before it is affecting into the disk block, means before it is performing output of BA, if there is a loss of power in the main memory, so that it is going to lose the contents. If it is losing the contents, buffer block contents are not affected to the physical block. So how it can ensures that the transaction T is completed? For this means there is a loss of data in the main memory. So whenever a transaction commits, it requires to maintain some information about the transaction. How? Let me explain. Whenever a transaction started T, it is going to write one log record. It is going to write one log record. That log record, what that log record do is, what that log record do is, that log system is going to maintain a log record, maintains information about the transaction. That whenever a transaction start, it is going to write a log called transaction started. Okay. Then input buffer block. Again, I'm telling you all the operations. Input buffer block A. So buffer block A is bring into the physical block is bring into the main memory. Now next read A. So from the buffer block, it is going to read that corresponding value of A into register. Then perform addition. Say assuming the value of A is 1000 rupees or else 2000 rupees. It writes 2000 plus 1000. Plus 1000 makes the value of A in the CPU register is going to be get affected 3000. Then this updated value write to the buffer block. In the buffer block, it is going to be, previously it is 2000s. It is 2000s. Then it is affected to the 3000s. Whenever it is performing a write operation, before this 3000s write to the buffer block, it is going to write one log record stating that transaction T updating the data A whose previous value is 2000 and new value is 3000. This is going to be written into the log record. Then it is written commit operation. Whenever a transaction is committed, it is going to write a log record called transaction commit. Now the point is, once transaction committed, it is successful, even though this 3000 which is updated in the buffer block is not affected into the physical block. How I can say the transaction is successful? Then you may ask me a question, sir, here only main memory is updated, not the disk physical block is updated, because main memory is volatile. If power losses, the contents of buffer is lost. Okay, if the contents of the buffer is lost, the information about the transaction is available in the log. This is a log file. In the log file, whenever it reads the log file, it knows that transaction is started and also committed. Because transaction is committed, the updated buffer block is not affected into the physical block. Because not affected into the physical block, what it will do, use this information of the log records, where A requires to be changed from 2000 to 3000, so that this is going to be outputted into the physical block, changing the value of 2000 to 3000. So means even though a failure occurs in the main memory after the transaction commits, it is not causing any loss of information. Why? Because if the transaction is committed, the information about the transaction is available in the log records, log file. Using this log file, by reading this log records, it can able to update the physical block, so that we can say transaction is successful. That is a property of durability. Then you may ask a question, sir, okay, you are telling that you require to maintain a log records, happy. Okay, where you have to maintain this log records? Again, where you have to write this log records? Again, I will tell you that this log records initially requires to write in the main memory. But actually what it says is, whatever the logs you write in the main memory, it is also be written into a mythical form of storage. A mythical form of storage is called a stable storage. It is called a stable storage. Means parallelly information about the transaction is going to be stored into the mythical form of storage, is called stable storage. Here I am calling mythical form of storage, means there is no such there is no such form of storage. But what is the meaning of stable storage is, the information stored in this will never be lost. That is the assumption. That is an assumption. That is called a mythical form. We are calling it as mythical form because the information may be lost, but assuming that the information will never be lost. Then you may ask your question, sir, what are you telling? So how you are maintaining that mythical, how are you maintaining that stable storage? Yes. How we are going to maintain? So this mythical form of storage you can maintain by having more than one disk storage. So here this log records are stored into disk 1, assuming. Then copy of these log records also stored into disk 2. And here assuming multiple disks of the different places, not in the same room, means these room and this room may be located, remotely located. So means it is assumed that if a terrorist attack occurred, the data in this room is lost, and because this room is remotely located, which is far from room 1, I'm calling it is room 2. Room 2 is very, very far from room 1. Then the data in the room 2 may be used to recover from the database. That is what we call stable storage. Then you may ask me question, sir, if world is completely destroyed, then how you are going to recover from the database? If world is going to destroy, then what is the need of data? Because everyone is gone. If everyone is gone, there is no need of data. That is what we call a mythical form of storage. It's called stable storage. What is an assumption? Keeping the same copies of data in more than one disk, or else more than one disk located in remotely in different places. So if it is failed occurs in one disk, maybe data is available in other disk to recover. If a failure occurs in all the disks of a particular place, the data in the disk of other places may be useful. That's what we can call it is a mythical form. It is a mythical form, means mythically means we are assuming that that is possible. We are assuming that that is possible, but frankly speaking, that nothing is permanent in the world, right? Nothing is permanent in the world. That's what we can call stable storage is a mythical form of data. Now, what we understood now, if any transaction is going to be executed, information about the transaction is going to be maintained in the form of log records, where it is to be maintained in stable storage. If it is, what is a stable storage? It is a mythical form of storage. What it is assumed that data in that storage can never be lost, okay. And if any loss of information occurs, either maybe in the CPU registers or in the buffer blocks or in the physical block, then information in the stable storage will be useful for recovering data from the database. Okay, chalo. That's about how it is going to maintain. Now, as I told you, it requires to maintain log records. So means this type of recovery is called log-based recovery. That type of recovery is called log-based recovery. Log-based recovery. Log-based recovery. Okay. Now, what is log-based recovery? It requires to maintain information about the transaction in the form of records. That records are called log records. It is called log records means it is maintaining the activities. Okay. Now, let me explain. Here there are two types of log-based recovery. There are two types. One is called immediate database modification. Immediate database modification, and another is deferred database modification. Deferred database modification. So what is the meaning of immediate database modification? What is the meaning of deferred database modification? Immediate database modification means as soon as it is performing a write operation, the update is going to be affected into the buffer block immediately. If it is deferred database modification, means deferred is also called a synonym called delayed. So means update is not immediately affected into the buffer block. That update is going to be delayed until the transaction commits. So means that update is going to be affected into the buffer block only after the transaction commits. That is called deferred database modification. Now let me explain both parallelly, and I will show you some questions also. If any transaction is going to start its execution, it is going to write the transaction ID called and start log records. The transaction ID comma start log records. If any transaction updating the value of some data item A, say TI is updating some data A whose old value is V1, whose new value is V2. Because update is immediately affected into the buffer block, so that it requires to have its old value to be stored. Suppose if the update is not affected to the buffer block immediately, it means old value already there in the buffer block, only new values required. If any failure occurs, only new values required to recover from the database. Okay, and it requires only new value. Here let me write instead of V1 V2, I'm writing old comma new, because modification is delayed, already buffer contains old value, so it requires only new value. And if a transaction is committed, then it writes a log called TI commit. TI commit. Now let me explain one small example. Suppose there is a transaction T that is updating the balance of account A. Say what it requires, read the current value of A, and A equal to A plus 1000, and performs write A and commit operation. Okay, this is T1, and there is one more transaction T2 which is reading B and debiting 1000 rupees from B, write B and perform a commit operation. Now if these two transactions are executing serially, what it is going to do, assuming first T1 started. So here I will explain you some cases. Case 1, first T1 started, so it writes a log called T1 start. Assuming the value of A is 2000, value of B is 3000. What it will do, T1 started, okay, it reads A, read into the CPU register 2000 plus 1000, 3000. Because it is immediate modification, it is 3000, 2000 plus 1000, 3000. Because it is write A occurs, it is immediate modification. So means it is affected into the buffer block. A is to be affected with 3000. Before it make any modifications, what it will do is it will write a log record T1 updating A whose old value is 2000, which is there in the buffer block, and new value that is going to write is 3000. After writing this log records, this 2000 is changes to 3000. Okay, now after this it is updated only in the buffer block. Do remember, it is only buffer block, not the disk blocks. Next, what it will do is it is going to perform a commit operation. T1 commit. Okay, done. Suppose if a failure occurs, it is a case 1. Here, if a failure occurs, what is to be done? what is to be done? Simple. If a failure occurs, what it will do is it will read the log records. Failure occurs means it read the log records. It read the log records and scan the log backwards, and it observed that we have a log record T1 start but no T1 commit. It means transaction 1 is not committed. Because transaction 1 is not committed, so what it will do, it has to change the value of A from 3000 to its old value 2000s affected. That's it. So this is operation is called undo operation. It is going to perform undo of transaction 1. So how undo operation is going to be decided means if the log contains only start but not commit, so means it requires to perform undo operation. Now let me give a case 2. First T1 started, write a log, and T1 updating A from 2000 to 3000s. Okay, now from 2000 to 3000s it is updated. Okay, fine, it is updated. Then T1 committed. T1 committed. T1 committed means transaction 1 is completed. T1 committed. Transaction 1 completed. Next, completed, it is not mean that this buffer block is affected to the disk. Next, T2 started. T2 started. And T2 read B. This is going to read 3000s. Minus 2000s. Minus 1000, 2000s. Write B. Before it performs a write B, it is going to write a log T2 updating B, whose old value is 3000s and new value is 2000s. Return. Okay. Then performs a write B. Because it is immediate modification, this 3000s changes to 2000s. Okay. Done. Suppose if a failure occurs. Suppose if a failure occurs. Means before T2 committed, if a failure occurs, what it will do is it is going to read the log backwards. While reading the log backwards, now T2 having only start but not commit, then what it has to do, it has to perform undo operation. Undo of T2. Undo of T2 makes the T2 old value, T2 new value is 2000 to be changes to old value. Means this 2000s is changes to 3000s. And while scanning log backwards, we have a T1 commit and T1 start, means transaction 1 is committed. So transaction 1 is committed means the buffer block that containing 3000 should not be disturbed because it is completed. So it means it requires to perform a redo operation, redo of T1. Redo of T1 means again this 3000 is going to write with 3000s. Just this is going to be done because it is required for the concurrent executions. Means if multiple transactions are updating the same data simultaneously, so in the same way simultaneously it is to be updated by it is going to be perform the same updations, redo. That is called redo operations. Now here you observe, when we are performing undo operation, we are performing undo if log contains start but not commit log. Right now, when we are performing redo operations, we are performing redo if log contains both undo and redo logs. Sorry, both start and commit log. Both start and commit. If both start and commit means transaction is completed, it requires to perform a redo operation. If it contains start but not commit means it is undone. Undo it. Okay, these two operations we have to perform it. Same thing here also we'll discuss. Same example I'm continuing. T1 is reading A and adding 1000 rupees to account A, updating A, commit operation. And T2 reading B minus 1000 write B commit. Okay, now here the buffer contains the values of A, which is equals to 2000s, value of B, which is equals to 3000s. Okay, now first case 1. First T1 started, it writes a log. Then T1 reads A, that is 2000s, plus 1000, 3000s. It is updated into the CPU registers. Before the 3000 write to the buffer block, it is writing a log record T1 updating A, whose old value is 2000s, new value is 3000s. This is log is written. After log written, this is going to write this 3000 to the buffer. Okay, it is buffer. But what type of modification it is? Deferred database modification means database modification is delayed. Database modification is delayed means it may be updated into the buffer, may not be updated into the buffer immediately. Okay, it is updated or may not be updated immediately. Okay, even though it is committed. So means all the database modifications are delayed until the transaction commits. So until commit, it is not affecting immediately to the buffer. Because not affected immediately to the buffer, what buffer contains? Only 2000s. But what is the new value? 3000s. Because buffer anyhow containing the old value, the log doesn't require the old value to be maintained separately, because previously old values changes to new value. That's why we required both old and new values. Now anyhow old value is there in the buffer, log requires to maintain only new value. Why new value is required? New value is required if transaction completes but not affected into the buffer block. New value is required to update the buffer block. Okay, keep in mind. Now T1 commit, and do remember this commit not requires this update 3000s. Okay, 3000s to be affected into both buffer and disk blocks. Suppose if a failure occurs, now tell me, if any failure occurs in the case 1, it requires to read the log. Log is going to be right. Now here we do have a T1 start but no commit. Because T1 start no commit, is it required to perform undo operation? Undo operation is required? No. Why? Because the old value already there in the buffer. Buffer is not affected because modification is delayed, deferred. Because modification is delayed, so buffer is not affected. Is it required to do anything? Nothing. So means do nothing of T1. Okay, nothing to be done. Suppose we will discuss a case 2. T1 started. T1 updated A and with new value 3000s. Write A not guarantees to be affected into the buffer. Now once T1 committed, it means the buffer is going to be updated with value 3000s. Previously what happened? It is updated immediately, but now update is become delayed. This 2000s is changes to 3000s. Okay, now once buffer updated, next T2 started. Now T2 read the value. 3000s, minus 1000 2000s, minus 1000 2000s. Before it writes 2000s, what it will do is it writes a log T2 updating B, whose new value is 2000s and not affected to the write is not affecting to the buffer immediately. That point you keep in mind. Now a failure occurs. Now what it will do? Again it reads the log backwards. While reading the log backwards, T2 is having start but not commit, means T2 is incomplete transaction. Because T2 is incomplete transaction, updates of T2 is not affected to the buffer, and buffer is already with old values. So what is to be done with T2? Do nothing with T2. and scan log backwards. T1 commit, T1 start is there. Means T1 performed both start and commit. So it means this new value is updated into the buffer block and also updated into the disk block. That is what we call redo operation. Redo of T1 means this 3000 is to be redone to 3000s into the buffer block, also into the disk block. Okay, now what is required? Your deferred database modification requires only redo operation. Your immediate database modification requires both undo and redo. Why both undo and redo is required? Immediate database modification, because database modification is done immediately to the buffer, so that if any failure occurs, it should changes to old values. That's why it requires undo and redo. But in deferred database modification is delayed, so that it doesn't require undo, only redo operation is required. Okay, now when it is going to perform a redo operation, when it is performing redo operation, while scanning the log backwards, it has to verify the log records. If log contains, both, one minute, the log contains both start and commit. Okay, this point you keep in mind. Okay, this is how recovery is going to be done on a database system. Okay, using immediate database modification and deferred database modification. And one more concept is there called checkpointing also. What is the checkpointing also? Let me explain, so that I can continue with the questionnaire to be solved. So here I'm going to discuss another concept is called checkpointing. What is mean by checkpointing means periodically updating the disk block, of buffer blocks are affected to the disk block, so that updates are permanent. If the updates are permanent, then if any failure occurs, you need not to start scanning the log backwards till to the beginning. Suppose, let me explain a simple example. Here we do have a log T1, some log records are there, say hundreds of log records are there, say log record 1, log record 2, log record 3, right? So after log record 10, I'm putting a checkpoint. What is the meaning of checkpoint? Means whenever you write a checkpoint log record, what it requires is update all buffer blocks to disk, because update all buffer blocks to the disk means whatever the updates are there, that is going to become permanent. Okay, and store the log records above the checkpoint. Store the log records above the checkpoint, to stable storage, so that this log is not going to be lost into stable storage. Then what it is to be done, it has to continue by writing the new log records 11, 12 dash up to 20, assuming 11, 12 up to 20. Say assuming after every 10 log records I'm putting a checkpoint, say 20, and perform a checkpoint. Write one log record called checkpoint. And this one is going to be continued 21, 22 dash 30, and perform a checkpoint. And then 31, 32 dash. Here if a failure occurs, can anyone tell me, if a failure occurs at this point, is it required to recover? Is it required to scan the log till to the beginning? No. Why? Because whenever a checkpoint is in progress, all the buffer blocks are affected to the disk, means updates are become permanent. And whatever the log that is there before the checkpoint is stored into stable storage, means even if there is a loss of these log records from the main memory, that log records are available in the stable storage, so that recovery is possible. Then in such cases, the log has to be scanned till to the most recent checkpoint. So up to this, it has to scan and perform the recovery process. Means it doesn't require to scan the log entirely. What is the advantage of checkpointing? Need not scan the log till the beginning. Need not scan the log till the beginning. Only scan the log till to the most recent checkpoint. And perform either undo or redo operations according to the modification techniques you are using. Suppose if it is immediate database modification, it requires both undo and redo operations. If it is deferred database modification, it requires only redo operations. That one you have to do it. This is what we call checkpointing. This is when you are typing a document, in the frequent intervals you will be clicking on save. If you are frequent, you are clicking on save. If suddenly power losses, your contents are available, your contents are not going to be lost till to the point where you have most recently clicked on save. So whatever the data that is there in the most recent save, that data is going to be permanent. Some data may be lost, that you can get, that is possible, that you have to do it. This is what we call frequently clicking a save button while typing a document is called checkpointing. It's just a normal example I'm relating to it. This is a process happening in the database system. This is how, if a failure occurs, if a information loss occurs, then system has to recover from the loss using the technology of log-based recovery and using the concept of checkpointing. Is it clear? Any doubts? If any doubts, you can ask me now. So I keep on telling without any break, and I didn't give any time for you to ask me any doubts. I hope you understood. Any doubts? Hello. Have you understood? Is it audible? Are you there? Yes. Okay. Chalo. Here I will show you a few questions. If possible, please try this. Have a look of this question. Can anyone please answer this question? Please try. Take 2 minutes of time and try. Please answer me. Any answer? Please try. Don't ignore. That may be helpful. E. Very good. Who's that? Naga Karthik Pedisetti. Okay, good. Anyone else? Okay, any other answers? Okay, let me explain. Okay, fine. Consider the following example of a log of two transactions where immediate database modification scheme is used. Details of the log is given. If a crash occurs just after step 7, here crash occurs means a failure is there, a crash occurs, maybe disk crash or transaction failure, something, okay, something happened, right? If the recovery of the system is successfully completed, which of the following is actually true? Just check it out in the log backwards. We have a T1 commit is there. If commit is there, it is to be added into the redo list, redo of T1. Scan log backwards. T1 start is there. T0 only start is there. Do you have a T0 commit? No. If T0 is not committed, it requires to perform undo of T0 and redo of T1. Redo of T1 we require. Why? Because T1 is having both start log and commit log, and T0 is having only start log but no commit log, so that T0 is to be undone. So what is the answer? T0 undo. Okay, T0 redo, incorrect. T0 cannot be redone. Why? Because it is not committed. Option A wrong. T0 undo, correct. But T1 it requires to be redone. Why? Because T1 is committed. That's why option B is incorrect. T0 undo correct, T1 redo correct. That is options. Is it clear? Is it clear? Understood? Naga Karthik. Okay, fine. Just let me give one more question. Okay, could you please try this fifth question? This is based on deferred database modification. We call delayed database modification. D. Very good, Naga Karthik. Only Naga Karthik is there. What about others? Vamshi, Shiva, Surendra, Akhil, Teja. So many were there na, in your class. Anyone else? No? No? Okay, fine. Here, if a crash occurs just after step 6 and recovery of the system is successful, which of the following action is true? T1 commit is there. So T1 is to be added into the redo list. T1 commit, T1 start is there. T0 start is there, but not commit. So because T0 start is there, but not commit, anyhow database modification is delayed. It means old value is there in the buffer block only. Old value, because buffer block is not affected. Is it required to perform undo of T0? No. And what is to be done with T0? Do nothing. So means no action to be taken for T0. No action of T0. Option A, T0 redo, wrong. T0 redo, wrong. T0 redo wrong, T0 no action right, T1 redo correct. So option D. Very good, Naga Karthik Sethi, nice one. Okay, sure. Will you try one question on recovery? Sorry, on checkpointing. This question, seventh question. It is not fitting in one page, na? If I make it more shorter, it is not good. Fine. Okay, just options are based on the redo list and undo list. Which transaction need to be redone in this question and which transactions need to be undone? That you please try. Any answer? What is there in the redo list? What is there in the undo list? Please try. That is, the question is based on the checkpoint. Redo T2, undo T3. Okay, Naga Karthik. I think today now only Naga Karthik is listening to my class. Okay, rest all are maybe tired because you have written some exam. Okay, I can understand. At least you listen to that recorded lecture. So I'm going to upload it. Okay, fine. Chalo, let me explain. Here, look at if there is a crash just after step 12. Here, if a crash occurs, if a failure occurs, then identify the incorrect actions for the above statements. Okay, fine. Now I'm asking you, because options are not shown, I'm asking you what is the undo list and what is the redo list. And what Karthik given? Okay, T2 redo and undo T3. Okay, look at when the scan is logging backwards. When the log is scanned backwards, T3 start is there but not commit, so that T3 is to be in the undo list, and T2 commit is there. Commit, it is there in the T2 or redo list because it is having start. Checkpoint T1. Checkpoint T1 means it has to scan the log till to the most recent transaction. So above this, because when checkpoint is in progress, T1 is not completed. So because T1 is not completed, it has to scan backwards, but we don't have a T1 commit, so that we don't have a T1 commit. T1 is to be performed, T1 to be added into the undo list. T1 has to be added into the undo list. Now undo list should contains both T3 and T1. Redo list contains T2. Okay, that is the answer. Here, what is an option A? Redo list contains T2, correct. Undo list contains T3 and T1, correct. But question is about incorrect, na? So this is a true statement. And like after recovery, what will be the values, that all also given. But here I asked you question, what is a redo list, undo list? Redo list is T2, undo list is T3 and T1. Why? Because while checkpoint is in progress, T1 is not committed, so it is to be added into the undo list. Fine. Okay, Naga Karthik. Okay, done. Nice. Fine. That's how recovery is going to be performed in a database system, so that if any failure occurs, it is possible to recover from the failure. Fine. And finally, just I wanted to give a little introduction about indexing. Why? Because even index is also important, which is the last topic for you. We'll discuss a little about indexing. What is for indexing? Why do we need index? Index is required to search. Index is required to search the record fastly. Means index is required to faster accessing of the record. Faster accessing of the records. Why do we need index in the textbook? Suppose if I ask you to open a particular chapter in the textbook, what will you do? First, you are going to see the page number of the book in the index. It means if you have an index, searching it is going to become faster. That's why we require to have an index. Okay. Now, index is required for faster accessing of the records. And there are various classifications of index depending on what attribute you are going to create an index. Here I'm going to discuss the classification of indexes. Here index are broadly categorized into two classifications called single level indexes, and one more is called multi-level index. Two broad classifications. Single level index means on one table there is only one index. That single level index you can create on any attribute of a table. Depending on which attribute of a table you are creating index, that index is classified into different types. Suppose if you are creating index on primary key of a table, then it is called primary index. It means primary index is created on primary key of the table. If index is created on non-key attribute, non-key means which has a duplicate, attribute has a duplicate. Suppose if index is created on non-key and the file is ordered on it. If the file is ordered on duplicate column value, means all the duplicates are going to appear at once, appears together. Such index is called clustered index. It means it is going to be created on non-key plus ordered. And third one, secondary index. Secondary index means it is going to be created on candidate key of the cal, means other than primary. Other than primary means maybe on non-key, other than primary key, may have some columns duplicates or may have some columns with no duplicates. We can call candidate key. It is going to be created on unordered file. You know what is the meaning of ordered file, unordered file. Ordered file means file is in the sorted order based on some attribute. Suppose if the file is ordered on primary key attribute, it is going to create a primary index. It is called primary index. If the file is ordered on non-key attribute, we call clustered index. Other than primary key means other than primary key, we call file is unordered. So other than primary key means non-key or candidate key, we call secondary index. And we do have other broad classification called multi-level index. Actually, multi-level index means like your textbook is having index for chapters, topics, subtopics, and its subtopics, and so on. That is called multi-level. So the multi-level index is represented like an hierarchical structure that is implemented using B tree data structure, B plus tree data structure. And we do have various other types also. So means generally this multi-level indexes again will have a two types. Okay, this first let me explain. Multi-level indexes are implemented using different tree structures. We call ISAM, we call indexed sequential access method. This is a tree structure: indexed, sequential, access method. Actually, ISAM is a static in nature. This is a static tree. So a tree is fixed. To the tree, we are going to add some overflow chains. In-depth knowledge is not required. The multi-level index is implemented using ISAM, and one more is B tree, and one more is B plus tree. And actually, the index will be again of two types: maybe ordered index, unordered index. Index should be ordered index, and index should be unordered index. Means index may be ordered file or unordered file. Unordered index. What is ordered index? Index should be ordered index. Ordered index means your primary index, your clustered index, your secondary index, or all called ordered index. Means that index file is always ordered. What is unordered index? We call hash based index. Hash based indexing is called unordered index. Maybe you have studied hash based techniques in data structures. We do have two types of hashing: linear hashing and extendable hashing. Extendable hashing. And actually, linear hashing is in static nature, and extendable hashing is in dynamic nature. Okay, these are called unordered indexes. Okay, and generally, unordered indexes are suitable for random searches. Suitable for random searches means if I wanted to search something randomly, you can use hash-based indexes. But ordered indexes are suitable for both random searches and sequential search. Sequential search means I wanted to access all the employee records from this range to that range. Likewise, sequential searches. So it is suitable for both. Sequential searches, or also we call range searches. More appropriate word to be used is range searches. So means I wanted all records from this record to that record, some particular range. But for range searches, unordered indexes is not suitable. Only ordered index is suitable. Okay, this point may be helpful for you. Okay, these are the some concepts. Just a little knowledge I gave you, like not even 1%, also 0.001%. Some knowledge I gave you. Maybe this knowledge will be helpful for you in your placements. Okay, that's about indexes. So that because the database is a huge amount of data, among the huge amount of data, it is going to access any data fastly. It requires to access any data fastly, because to access any data fastly, we have to use index. Okay, and these are the classifications of indexes. These are the classifications of indexes, and what are the types: single level, multi-level, ordered indexes, unordered indexes. Ordered indexes are suitable for both random searches and range searches, and unordered are suitably only for random searches, not for range searches. Okay, these are the some of the concepts of indexing. And based on indexing also, some of the InfoTQ questions are available with me. Just let me share with you so that the complete thing we are going to understand. Of this question, have a look of this question. This is InfoTQ question only. Look at, let me tell you. Consider a table order with attributes order ID, primary key. Consider customer ID, order date, quantity, price, category. Columns, customer ID, order date, quantity, and price are non-unique. Non-unique means duplicates may be there. The table has two explicit indexes. Two indexes are there on the table as follows. One index is on quantity, and another index is on together customer ID and order date. Okay, Now, which of the following queries will not result in table scan? And if index is there, it doesn't require a table scan. Means if index is not there, suppose if I do have indexes on, suppose I do have index on student roll numbers, then you need not to search sequentially the students roll numbers. Suppose we don't have index on marks column. If we don't have an index on marks column, we have to search all the marks sequentially. The question is, if we have an index, now what question says, which of the following queries will not result a table scan? Will not result a table scan. Table scan is not required if it has an index. If it has an index. If it has an index, no table scan is required. Look, here you look for the conditions where lower of category equal to stationary. So means it has to search the records based on the condition category. But do we have a index on category? No. Do you have an index on price? No. Because index is not there on category and price. Is it requires a table scan? Yes, it requires a table scan. But question is not result in a table scan, means it requires to have an index. That's why option E is wrong. Option B, where customer ID is C101 and order date. So index is there on both customer ID and order date together. So that it requires it. Is it requires a table scan? No table scan. So directly you can search using the index. It is true. Because question is about not result in a table scan. No table scan is required for this B query. And C, where price less than 650. Do you have an index on price? No. Here, yes. Do you have an index on order ID? No. So, no, it requires a table scan. So, option C is wrong. Option D, where customer ID equals C1005. True. Quantity is greater than 10. But we do have index on customer ID, and moreover, it is asked you to choose two correct options. So suppose if it is MCQ, I can choose only option B is correct. Option D is not much correct. Why? Because it is having it is required to search based on the customer ID. So, but index is there on both customer ID and order date. So that what we can do is using the customer ID, directly we can access some of the records of that particular customer ID. Later we will check for the other quantities, other attributes. So means this is also requires a table scan. It is also requires no table scan. Why? Because it is possible to access using the customer ID. Yes. So more appropriate is option B. Because it is asked us to choose two options, so that I can say both option A, B and D is correct answers. Both option B and D is correct answers. Is it clear? Okay. Will you answer this question? Please, can anyone answer this question? Can anyone answer this question? Take 1 minute of time. It doesn't require much time for you. Very good, now Karthik. A and C, right? Okay, nice. Simple. Here, what is the question? Which of the following queries will result in index range scan? Will result in index range scan. If index is there, searching is possible. Now, where category equaled bulk order, do you have index on category? No. Do you have index on order ID? Yes. So will result an index range scan, will result, yes. And here B, customer ID equal to C105, yes. Order date, yes. It is direct, it requires to search each and it requires to go for directly. But is it required to search range? No. 1 minute here, just let me explain first. It is not a table scan, index range scan it is given. Okay, let me check. Customer ID, yes. Quantity, no. Order ID, yes. Customer ID, yes. So what is required? So it is a direct access. Only one, directly. We do have index on both attributes. Look at option D. Index is there on both attributes, means directly you can go to that particular record. Right? It doesn't require a range. Means it doesn't require a range of tuples to be searched. Here also you look, both are there. It is also requires direct. Directly I can go to that record because index is there with both customer ID and order date together. But in the option A and C, so we do have index on order ID, okay, but category is not there, so that it requires such the range of records. Here also we have an index on customer ID, but no quantity. On a quantity, it requires such range of records. So both A and C is correct, and B and D is incorrect. Fine. These are the kind of questions are possible or asked in the previous year InfyTK questions. With this, all InfyTK questions also we have solved. Okay, one more is also there. Please try this one more. Here you look, index 1 is on job title and wages per day. Which of the following queries will use table scan? Which of the following queries will use table scan? Here, that is based on the where class only you should check it. Worker ID. Do you have a index on worker ID? No, because no means it requires a table scan. We'll use a table scan. A requires a table scan. And here condition is on job title. Do you have index on job title? Yes. So table scan doesn't require. Here also job title. Yes, doesn't require. Here wages per day. Here yes, wages per day. Yes. So what is the question? Which of the following queries will use table scan? But here you look, worker ID, we don't have index. It requires to use a table scan. But index is there on job title. Okay, index is there on job title. Yes, index is there on job title. Yes, here index is there on job wages per day. Yes. So what we can do here, using this job title and wages per day, we can go directly to that particular job title, like job title electrician. If index is there based on job title, using that index, we can directly go to the electrician, these two records. And then what is required to select? It requires to select mobile number from worker. Mobile number, it has to perform a scan of these two records. To scan of these two records, it requires to search table scan. Table scan is required. But question is about choose two correct options are given. Two correct options means okay, it requires to search table scan. And carpenter job title, carpenter 1, 2 records are there. And again, these two records is to be searched for worker ID, mobile number, and job title. Table scan is required. And here wages per day greater than 300. Wages per day greater than 300. True. So more records are there. But what is required here? Here what is required? Mobile number, worker ID is required. Mobile number, worker ID means these records and these records has to be searched. So means more appropriate is both option A and D, and B and C is not that much appropriate. Instead of asking me to choose two correct options, if it is saying one, then option A is perfectly right. Option A is perfectly right. But because asked me to choose two scans, so I can go ahead with option D. So fine. With this, I have completed all the InfyTK questions also, and thank you. Wish you all the best. Good luck, and thank you one and all for your patience and listening to all my lectures. Thank you, everyone. Okay, thanks for your support. If any help is needed, don't forget to call me. Definitely, I will help you. Don't worry. Okay, but please give me a prior intimation. So definitely, I can help you for cracking your interviews. Thank you.